Hello everyone. Enzyme-linked immunosorbent assay, abbreviated as ELISA, is a highly sensitive immunodiagnostic technique which is the improvised form of RIA or radioimmunoassay. Here the label used for visualization is an enzyme instead of a radioisotope, thus eliminating the health hazard for the workers. It was first conceptualized and developed by Peter Perlman and Eva Engvall at Stockholm University, Sweden. ELISA utilizes an appropriate enzyme to tag the antibody. This, upon reacting with the antigen present in the body sample being tested, yields a colored product upon addition of a chromogenic substrate. This confirms the presence of the antigen in the sample, and the intensity of the appearing color is directly proportional to the amount of the antigen in it. Mostly, the antigen is first immobilized on a solid surface to carry out ELISA, which is why such tests are called immunosorbent assays. Enzyme-labeled antibodies serve as a powerful probe to detect the antigen in the sample, but the opposite can also be done. That is, labeled antigen may be also used to probe for the presence of their antibodies. Visualization of the color is done by measuring absorbance readings spectrophotometrically by an instrument called the ELISA reader. Enzyme immunoassays can be used for the detection of either antigens or antibodies in the serum and other body fluids of the patient. In ELISA techniques, antigens or antibodies are labeled with enzymes such as alkaline phosphatase, horseradish peroxidase, and beta-galactosidase. Talking about the substrate specific to the enzyme, orthophenylene diamine dihydrochloride is used for horseradish peroxidase, producing orange-brown colored product, whereas para-nitrophenyl phosphate is used for alkaline phosphatase, producing yellow-colored para-nitrophenol. The principle of ELISA, stated straightforwardly, is that when the sample containing the antigen is subjected to the enzyme-labeled antibody and the colorless but chromogenic substrate is added to the same, a colored product appears. Its amount and intensity measured with a colorimeter at a specific wavelength of light reliably indicates the amount of the antigen. ELISA is primarily of four types: direct, indirect, sandwich, and competitive ELISA. The first is direct ELISA, which is the simplest and quickest among all types of ELISA. A single enzyme-linked antibody is used which directly interacts with the antigen present in the sample. The procedure involves adsorption of the sample containing the antigen to the solid surface, then washing to remove the unbound antigens, addition of an enzyme-linked antibody that reacts with the antigens if present, followed by washing to remove the unbound antibodies, now addition of the chromogenic substrate, and visualization of color change and the interpretation of results. Its applications include identification of biomolecules as well as pathogens. The second one is indirect ELISA, which was developed in 1978 and is currently the most popular type of ELISA in use. Here, first the antigen in the sample is adsorbed in the microtiter plate well. Thereafter, the first antibody is given to it, which binds if the antigen is sticking to the solid surface. This is termed the primary antibody. Then it is followed by a washing step. A secondary antibody linked with the enzyme is furnished now, followed again by washing and exposure to the chromogenic substrate till the desired color appears as a result of the product formation. Indirect ELISA is much more sensitive and economical than direct ELISA and hence is more popular. Here the same secondary antibodies may be used for detection of a number of antigens, since the secondary antibody binds to the Fc portion or constant portion of the primary antibody, which is really quite constant in its form and structure. Indirect ELISA applications include detection of HIV, rubella, dengue, viruses, etc. and to detect certain drugs in the serum. The third type of ELISA is sandwich ELISA, which was developed in 1977, and here two different antibodies are used. First is the capture antibodies, which capture the antigens or the sample, and the second one is the regular enzyme-linked antibody. The antigen of interest first binds with the capture antibodies, then the secondary antibody binds with the epitope of the antigen, forming a sandwich-like structure with the antigen in between the two antibodies. The procedure involves absorption of the capture antibodies on the microtiter well, then washing to remove the unbound antibodies, followed by addition of the serum sample containing the antigen, again washing to eliminate the unbound antigens, and addition of the enzyme-linked antibodies, followed by washing step, which is very crucial, and lastly the addition of chromogenic substrate and visualization of color development as a result of product formation. The sandwich ELISA applications is mainly used for detection of rotavirus and enterotoxins of fecal E. coli, and also for detection of pregnancy using pregnancy test kits. And the last one is the competitive ELISA, which was developed in 1976. It is based on competition. The basic concept of this type is that there occurs competition of binding between the sample antigens if present and a known quantum of the enzyme-linked antigens which we provide. If the sample contains the specific antigens of interest, they will bind to the antibodies and won't let the enzyme-linked antigens to bind with the antibodies. So then they are washed away, and hence after the addition of substrate, there won't be much color change, indicating a positive test for antibodies in the sample. Likewise, if antibodies in the sample are missing, the label will show in full swing in the immune complex, as the enzyme labeled antigens shall get the opportunity to bind. So the change here is that we use the labeled moiety, the same labeled moiety which we are trying to detect in the given sample. The steps of competitive ELISA are shown here on your screen. Competitive ELISA is mainly used for the detection of HIV and other pathogens. It is exactly the same as competitive RIA described in our previous video, whose link has been given in the description box of this video. Here the sample, which may or may not contain the antigen, is mixed with the known and pure antigen, which is enzyme labeled, and then is made to react with a fixed quantum of antibodies. The lower the label detected in the immunocomplex, the higher is the amount of antigen in the given sample. Competitive ELISA is one of the most sensitive and effective methods for the detection of different viral, bacterial and fungal infections, such as for HIV, dengue fever, TB and hepatitis infections and many others. Pregnancy test kits are also based on ELISA, which are available in the market. Also, ELISA methods are useful for detecting various proteins, hormones, toxins and food allergens. The advantages are that the protocols are simple, highly specific and sensitive, economical and safe for the user without any health hazard, unlike in radioimmunoassay. And the limitations are it is work intensive as many steps are involved. Preparation of enzyme-linked antibodies or antigens can be difficult and sometimes expensive also. Since the antibodies are unstable, so for transport and storage, proper refrigeration is required. Hope you liked our simplified description of various types of ELISA. It's worth a mention here, although previously when Burson and Yellow had given RIA, it was competitive RIA. However, it is implied that radioimmunoassay can also be performed as direct RIA or indirect RIA, just like direct and indirect ELISA described in this video. This is done except that the label changes from the enzyme label to radioactive label. We recommend that you watch our previous video whose link is given in the description box. We, Brahmjeet and Archana, thank our keen audience for watching and appreciating our work. See you soon in our next. Till then, bye and take care.